Part 2 of this introduction to R video will cover the remaining pieces. Part 1 had this part. Now part 2 will have the remaining parts. So part 2, item number 2 is fairly simple. You basically have information on how to do basic calculations. Some is very intuitive, like these pieces here are super intuitive, how to do addition, subtraction, multiplication, and division. Exponents, just make sure that if you have a negative, you use parentheses, but it's fairly intuitive. So let's move to the data part. So you have different types of data. You have numeric, and that means any number, whether it's a decimal or not. Integer would be just whole numbers. And then you have a logical data type, which could be true, false, or NA. NA basically means you're missing. You don't have data. So this is, think about it as missing data point. You could have a factor, which you could have a character, which is basically words or letters. So you could have a, male, or female. And you could also have factors, which is a combination of both numbers, integers, and characters. So in this case, this specific code line here says 0 would be for a male. It would assign any string that says male to a numeric value 0 and any string female to a value of 1. So that's about data types, and this may be important because when you're running regressions, you want to know if you're using numbers, if you're using factors. Also for graphing, when we use ggplot, you're going to need to know which type of graph you use depending on the items you want to have on your y-axis or your x-axis. Within data structures too, we have vectors. Vector is a container for objects of identical type, so that's important. Vectors in R index starting with 1, and think about a vector of a column with multiple rows. So for example, we could have something here that says, let's say we have a dummy variable for female, and then we could have 0, 1, 0, 1, and that, let's say these 4 numbers would be considered a vector. You can create a vector by using C parentheses. C stands for combine, and here we would be generating a vector that has 1, 3, 5, 7, 8, 9. Another way is to just assign, to store that vector into a variable, which we can call x. You can also use this other trick here, which if you use parentheses, basically it allows R to store the vector in a variable called y, and then you have the output. You could also use the function sequence, which tells you that it would go from 1.5, would be the first item in the sequence, to 4.2, the last item, and it would increase by 0.1. You can see that here, 1.6, 1.5, 1.6, and so on until it gets to 4.2. And you could do the same without having to say from equals to equals or by. Just look here. Okay. You can also use repeat. Repeat is pretty useful if you're trying to just generate the same items multiple times. So if you want to generate multiple A's within a vector, or let's say 10 times, you would use repeat or reap, open parentheses, A. Anytime you use a character or a factor, you need to, anytime you're using any kind of word, you need to use the quotations. And you just get the answer here. You could do it also, you can avoid saying the times and just simply put comma 10. You can combine things. You can say, let's use C combine X, which we defined before, and then repeat this sequence 3 times, and so on. So you can definitely combine all of this and you get the output over here. The length is useful because it tells you the length of the vector, and you can do it for either x or for y, whatever vector you have. So your first task, and this is where I would like you to go to your RStudio and basically create a vector of 5 ones. So that's what you would like as your output. I recommend also that you run all of these lines of code within your RStudio and see what the output is. And when you do that, you don't necessarily have to do it within the RMD file. If you do, just make sure any code that you're adding would be within the R chunk. Otherwise, just do it over here. You can just copy paste things here. So your first task is to create a vector of 5 ones. The second task is, notice that the colon operator A colon B is just short to construct a sequence from A to B. So create now a vector that counts down from 10 to 0, and it should look the following. So this should be your output. And then third would be using the rep function. Take the additional arguments times as above, and each which tells you how often each element should be repeated, as opposed to the entire input vector. So use rep to create a vector that looks like this. You need 3 1s, 3 2s, 3 3s, and then repeat that again. So those are your tasks. The answer for task 1, 3 items will be, and all the tasks will be posted as a PDF on Moodle. So make sure you try them first as you watch the video, you pause, try them, and then you go to Moodle and see the PDF to see if you got the right answer. The next topic we're going to cover is subsetting. Basically here, if you have a vector, you may want to extract some of the elements. And to do that, we're going to use the brackets, the square brackets. So we have our vector x, which we created before, and it has 6 items. We can extract the third item by using the square bracket and just putting 3. We can remove the second item if we say x and then square bracket minus 2. We can subset 1 through 3, or we can get the items number 1, that is like the first, third, and fourth item, and so on. We can also create a new vector that has true, true, false, true, true, false, and it basically is going to show your elements from X where Z is true. And you can see that if we look back at the vector that we created before. Next is important to understand operations. I mean, you should be able to read through this, but you can do addition, you can add a scalar to a vector doing this. You can also multiply every item within the vector by a number, in this case by 2. You can also use an exponent. You can look at the square root of each element within the vector. You can look at the natural log of all of the elements within X, and you can do combinations. Logic vectors are also important, so we can look at whether X is greater than 3, so it's going to look at that element by element. So 1 is clearly not greater than 3, that's why you get a false, but if we look at the last item, 9 is clearly greater than 3, then you get true. And so on. You can look at whether X is exactly equal to 3, and then you also get these logical operators. You can do that as you go down. If you want to look at for equality in terms of whether a number equals another number, we use the double equal sign. If we want to use just a single equal sign, that typically is to a sign. So we have used that before. For example, when we set up a vector, we say X equals. So X is given that vector with the 6 elements. If we want to look at different, if something is different from each other, then we use this means different. You can think about it as, okay, if we wanted to write like this, but we can't do that. So the closest we get is the exclamation symbol and equal. And then it tells you more information here. If we want to use the and, it basically tells you that both conditions have to be met. You can use this as an or, so one or the other condition, and you get more examples that give you how to use different operations. Sum is a pretty good function. It basically sums the number of elements of X, so of the vector, that are greater than 3. As numeric, it's telling you it assigns a 0 or 1 to false or true. So in this case, you're not going to be using the logical type, but you have a numeric binary, 0 or 1, which is also a pretty good function, which basically it looks at a condition of X, so it evaluates condition as true or false and returns each index of X where the condition is met. So in this case, we want to figure out from X which items are greater than 3, and then you get the indices for those numbers. If we actually want to see the elements, then we need to do X before and then square bracket. Max is another good function, gives you the max within the vector, which gives you, okay, what's the index of the max element, which is the 6th item in this case, and which dot max is an alternative code for the above. So your next task, so task number 2, also it has 4 subtasks. First is for you to create a vector field with 10 numbers drawn from the uniform distribution, and for that you're going to use this function, run if, and store them in X. Item number 2 within the tasks is to using logical subsetting as above, get all of the elements of X which are greater than 0.5 and store them in Y. And item number 3, we get using the function which, store the indices of all of the elements of X which are larger than 0.5 in Y, and call it IY. And then check that Y and X, check that these two are identical. That would be your 4th and last subtask of task 2. Our next topic is data frames, which is critical because most of the times we're going to be using data frames. By definition, a data frame is a list of vectors, and each vector has a name. So think about a data frame as a bunch, like as a matrix, as a table, and each column within the table is a vector. And each vector can be of different type. And this is important for us as economists because we may have a vector that has, let's say, a dummy variable for gender that may be female or male. And you may have also a vector where you store income. So you have numbers there. You could have another vector where you get the answers for a question about beliefs in climate change. So if you're doing any sort of survey, or if you're getting data from any survey, you're going to have different types of data or different answers within the question. So it's important that you can have a vector that has a different type within your data frame. So that's the cool part. Data frame contains rows and columns. Rows typically consider an observation. So in this case, let's say if we're talking about a survey, we're thinking about each respondent would be one observation. If we're thinking about worldwide data, you can think about a country could also be one of the rows. So it's an observation. A column then becomes a variable or a characteristic or a feature of the observation. So I gave you the example of the survey before. If we think about countries, we can have a column where it says percentage of forest in the country. And you can have more information like that. So for now, when we do the ICA, we are going to use environmental data, but for now we're going to use the data that was exemplified to you guys in the textbook. So we're going to use a data set that is already part of R. So we simply are going to bring it in. We store it by using, again, the equal sign. The single equal sign is assigning. So store data set in empty cars. You can name it something else. You could have done here like data instead of empty cars, but it's easier to just keep the same. And then I'm going to show you that the first, this function here gives us the first 2 rows within that data. Why the first 2? Because it says n equals 2. The default is 5 rows. So let's run those in R. And this is important that you do back and forth. So I already copied everything, but what I want to show you really is that once you run line number 7, and you can do it again, Alt Enter, or you can select it and then click Run. But you're going to see that on the top right, you see your data, and you can actually click on it and see how the data looks like. That's pretty useful, and you should definitely try to do this when you start working with data. Open it, get familiar with it, and so on. So that was the first one. The next one is just giving us the first 2 rows, just as it said on the notes. But if we want to do the default, it shows us the first 5 rows. The structure is very good, and let me go back here so that we get some more information. But the structure is going to give you more information about the data frame. So important things, we know we have 32 observations, 11 variables. These are the columns or the vectors that we have, and it tells you the type. So all of them are numeric, but you could have had a factor, you could have had a character. And always we're going to use the dollar symbol to understand that it refers to a variable within the data, so a column. We can use this to understand more the data set. So you should never write this as part of your R file or your RMD file, because it's going to open a website or it's going to open the help within RStudio, but we can do it here, mtcars. So we always do it in the console, and you see that you get information here. So the description of the data, where it comes from, how many observations you have, what each variable means, and so on, and where it came from, what paper was it used for, and it even has some example that you could run. So that's very useful to know that you can always do that. As long as the data set is stored within an R package, you should be able to get that. If you bring the data from a CSV file or another file that is within your computer, then you cannot use the equal sign to get information about the data because it's not stored within the R system. You can also use the names. That's useful. So it tells you all of the names. And we know already what some of those mean, because we know that MPG is miles per US gallon. Sil is number of cylinders. Disp is displacement, and so on. You can read the rest. And then if we want to just get the column that is the miles per gallon, we have to use the dollar sign to extract it. So we do our data frame, and then once we do the dollar sign, we basically put the name of one of the columns or the vectors, and then we get the information. We can do that same for another column, and so on. This function is good because it gives us the dimension, both rows and columns, but you can also do number of rows. This is very intuitive because n row, clearly you're going to remember that it tells you number of rows. If we're talking about econometrics, this would be the sample size, how many observations we have. Ncols would be the number of variables that we have for those observations. So both of those are very useful. You can start looking at some conditions. So we can look at our data frame. Once we do the open square bracket, we are calling a condition within the rows. So it's going to check within the MPG column, is going to check which ones have a higher than 20 as information. And then I want that then to display 3 columns for that. And that's exactly what it does. It gives us, for the Mazda RX-4, we get 3 pieces of information. But all of this have the conditions that MPG have to be greater than 20. And we have some more information below. We can do the same. We can use subset. So now we put the data frame here first. And then the subset condition is going to be that the MPG has to be greater than 25. And again, we're going to select 3 columns or 3 vectors within the data frame. So now we get to your task again. So tasks 3 that are based on the data frames part is how many observations are there in mtcars, how many variables, what is the average value of MPG, and what is the average value of MPG for cars with more than 4 cylinders. So you need to look at a subset with this condition. The last part of the video is about programming basics, and we're going to cover loops and functions. In a loop, the programming repeatedly loops over a set of instructions until the condition tells it to stop. So in this case, we're going to go from I, that is in 1 through 5. So I is going to take the following values: 1, 2, 3, 4, and 5. It starts at 1, and once it gets to 5, it stops. Once it runs the loop with 5, and then it's going to print just that number. And indeed, we get that as an output. We can see that in R. So I can run the func. I already copy and pasted everything, but I'll run it, and then you see the same output. We can also do a function that is not looking in numbers necessarily, but is going to look at 3 words: mangoes, bananas, and apples. If you're going to use words, make sure you use the C, the combine. You want to pass a vector of strings. And then you say the function is going to be print, and then you are going to use these other functions. So you can use a function within a function, and you use paste, and then you say I love, and then the fruit. And that's precisely what you get. You can change it to the fruits you like. So you can run it. You can change it to other things if you don't like mangoes, bananas, or apples. And then we can do another loop where it goes from 2 to 3. So it's really going to run twice on the outer loop. That's the first nest. And then for the second nest, it goes through the 3 fruits. And is going to print, and again, we use a function within a function. Can I get I would be the number. So it goes up to the first loop, 2. So the first time is going to do 2, and then J starts with mangoes, please. And that's exactly what we see on the first row. It continues doing the same for bananas, apples. That completes the first I. And then it does the same for I number 3. So it repeats the same process. When you copy and paste this from the PDF, you're going to see that it's going to take the 9 with it as you select the entire text. So make sure you remove that 9. So, and again, I can show you how this works. I can change it. I can say, can I get like 4 to 5 if somebody's really hungry, and we can run it, and then you get different numbers. And we can change the fruits too. Now we can also create functions, so that's the second part. Some are built-in functions like print, paste, and so on, but we can also create some. So a function is a set of instructions that are executes for us, much like those collected in a script file. So we can create a hello function, and this function basically is going to have is going to paste you are most welcome, and then it's going to add a name that is passed. So in this case, anytime we run hello open parentheses, it is going to write you're most welcome, which is this part over here, and then it gets Lord Vader, which is given as your name. But you can change this. You can put your actual name here or somebody else. So change the name if you want. And you can also change the other wording. The second function, let's say you have a teammate, you can say my teammate is X. So that's what you're going to pass in. And then you're going to say, and our team number is something else. And to run it, you're going to actually put, let's say the name, I don't know, like Peter, and then let's say it's team 1, and then you would run it. I can show you that function. We can do something else here, hello, and then you can put favorite dessert is, and let's say for me, I'm going to put chocolate, and then my favorite team is, I don't know, Juventus. It's a soccer team, but I can run this to just run the function, and then I can call it. And then it says my favorite dessert is chocolate, my favorite team is Juventus. You can change and do whatever you want with the functions. To conclude the lecture, then you're given your last set of tasks, task 4, which has 3 subparts. First is to write a loop that counts down from 10 to 1, printing the value of the iterator to the screen. Number 2, modify the loop to write I iterations to go, where I is the iterator. And 3, modify the loop so that each iteration takes roughly 1 second. You can achieve that by adding the following command. So you need to add this part below the line that prints I iterations to go.